Hariveer. I'm based out of Hyderabad Microsoft India Development Center, and I'm a program manager with the Visual Studio Test and Lab Management suite of products. So our team develops tools which are part of the broader Visual Studio ALM, which was earlier branded as Visual Studio Team System, and you would have faced this issue tons of time. This is your Friday, and your new build goes to the production. You have 2 weeks notice, and you already know your weekend is going to be screwed. How many of you can relate to it? Okay. Then there's another interesting thing. You make just one line change of code, and the production system is down. How many of you have seen this? And how many of you are still with the same employer? So these things happen very frequently. So that's the whole model of continuous delivery, and how does it fit into the agile methodologies. So these are the very common scenarios which we face in day-to-day life, but let's see if there are possible solutions for these complex scenarios and problems. Okay, before that, let's move into this manifesto for agile development. I'm not going to read it, but what are the broader things which it talks about? Individuals and interactions, working software, customer collaboration, responding to change. All these things relate to the previous scenarios. How many people use agile in some sense? Scrum, iterative, extreme programming. What's the most common? Scrum? How long is your sprint? 1 week? Anyone less than a month? In weeks? 2 to 4 weeks? So how do you manage your 2-week sprint? You have to do your planning, design, coding, testing, and actually making sure that product is testable and ready for release. So within 2 weeks, in this small period of time, you have to do a bunch of things. So in a sense, you would be continuously integrating with various branches, code branches, making sure that product is testable and ready for deploying into the production system. So that's what the whole idea of continuous delivery is. So there has to be a close feedback loop between you as a product team or the engineering team and the end users. Now what's the advantages of this closed loop? That's what we are going to cover next. But before that, let's say there's some bug fix you have to do. So as a developer, you just say, I'll do the check-in here, and it should be used by my customer. What do you think does it take to get your bug fix from your developer machine to the person using your application? How much time does it take? It's not a straight line. What we have here is a very complex system. Once you make a check-in, it actually builds the product. Once the build is product, it has to be deployed on your environments, which are your complex legacy systems. Once your application is deployed, someone has to test that to make sure that one line of code change doesn't bring down the production system. Once the application is deployed and tested, someone has to actually do the release management and deploy it on the production system. And then there's some other bug which comes in. So then you are always iterating through this. So this one line which we saw earlier has been replaced by this big cycle, which we actually call a cycle time. And if you talk about the continuous delivery. So how long does it take? Days? Weeks? Months? Years? We have seen some customers who might take years. They just accumulate bug fixes and then push it at a pretty late stage to make sure they don't have to inculcate this overhead of this big cycle over there. You need to make sure that its acceptance testing is done. Even the deploying the application on your environments to the legacy systems is not straightforward. Setting up those complex and legacy systems is not straightforward. To make sure that everything lines up, it's pretty much like the star needs to align to make sure that simple bug fix goes rightly and the customer is happy with that. So that's what the book definition of continuous delivery boils down to. It's an automated and repeated process for delivering software at a consistent quality bar. What are the things which are required to make sure that this automated and repeatable process always maintains that consistent quality bar? Right processes as well as the right tools. So what are the advantages one would get to if someone has to implement this continuous delivery model? Couple of things. One thing is, let's say you are a web startup. You know, web startup business is booming, and the other big companies are not giving a match to them. Why? Because they are delivering very fast. They don't have the legacy codes to maintain. They can do something, make a quick feature, get it out, and get feedback and fix it. But for the big companies, it's not that straightforward. So we need to make sure that this streamline of processes happen. So similarly, one thing is, if you are using this agile as well as continuous delivery, you are avoiding risks early. Even if your business logic or your business is flawed, you can at least try it, because you can get it done in a couple of weeks' time rather than years' time. So you don't spend wasting time for years and years, money and resources, and then realize this idea didn't succeed in the market. So to overcome that, if you have a very lean process where you can actually release things quickly, fast, agile, that's when the quality comes, as well as your risks are mitigated, and there's a close feedback loop between the end customers and the product team. Both of them at times live in silos. The product team is building features, and it takes months and years for them to actually give the product to the customers. And then the customers, they are not happy with it, and then they complain. By the time you have to fix it, it's too late. It basically boils down to doing some design change requests, DCRs, some architecture cleanup, bunch of stuff. So that's the whole philosophy and model of this continuous delivery and the agile processes. So what does it take to simplify things here? So these are the kind of industry best practices and which our team has been following pretty religiously. First thing, source control everything. It used to be called as source code control. Now it has been just called source control. Any ideas why this change? So the idea is, don't just have a versioning system for your source code. There are a lot of other artifacts which needs a central store, which needs a repository, which those artifacts could be your requirements. Make sure all those artifacts are in your central store, your test cases, your test plan, test suites, your user stories, requirements, and your build reports, your test reports. Everything should be in a central store. And needless to say, what are the advantages of a central versioning system? You can archive it, you can get the traceability, that one-line change code, what was the test impact on that. So make sure that everything is in your source control. There are companies which even put their specification documents in the source control. May not be truly in their central store. Other example could be some content management solution which provides the same support, like a SharePoint or other industry-wide tools. So the basic thing is, make sure that everything is in a central store. It builds up history, it builds up business and a traceability so that you can track things, what broke and how can we avoid it. The next thing, automation of builds. Over last few years, there has been a bunch of tools which help you automate your builds. For different technologies, .NET, Java, bunch of things are available. But make sure your build process is fully automated. The moment you put any manual step there, you are going to clog the system. Your chain is as fast as your manual step. Whenever the manual step comes in, it's going to clog the system. Make sure your build system is automated, and also make sure that you are building frequently enough. Make sure that you at least release a build every day. How many people follow the everyday build? What are the other frequencies which I can hear of? 2 days, 3 days, week, month? So weekly build, what does it mean is, there was another talk which I attended in the afternoon, which means that there are a bunch of check-ins which I've gone through, and there's no build which makes sure that those check-ins haven't caused any regression. So there is a risk which you have taken for a week, which you could have taken it in a 1 day. So you could have realized that the check-in which went on day 0, you caught only on day 8 when the build was finally produced, which you could have caught on day 1. So make sure that builds are automated and you keep pushing out builds as frequently as possible. I know at times it takes a lot of time, but it also requires a lot of investment from your resources. There has to be a strong farm of machines for the complex and the large projects, but building frequently and automating builds is very critical. The next step is pretty interesting actually. Now once you have the builds, how do you actually test the builds? That are the builds at least testable? There's no build break, but at least the application should be able to deploy it. Maybe some things will fail later, but the basic validation has to be done, which we call as basic validation, BVTs, or nightly automation runs, bunch of things which companies use. So there has to be a process which takes your builds and does the deployment of the application from the build. So if this process once again is manual, you are putting a manual step in your process. Any manual step just slows down the system. So best practice, have some system, have some scripts, and those scripts will take your build and deploy it into some environment. The next step is deploy on production-like environments. I'm going to cover it next in my demos as well. So let's take an example here. How many of you have seen that something works on your machine, but it doesn't, you are at well. How many people are developers? Testers? QA? Not many. Project managers? Okay. So how many people are, so bunch of audiences from developers, how many of you have resolved bugs as non-reproducible bugs? What it means is your tester filed a bug and you eventually said, it works on my box. Bunch of people, almost everybody. So what do you think? Tester was faking it? So the industry jargon, what it comes to is, it always works on the dev box, it sometimes works on the test box, it never works on the customer's box. And that is true. And all of us have faced that. So what it boils down to it, there's a production-like environment which we do not test on. So customer is using his own configuration. What tester is using, he's trying to simulate that. What developer is using is a one-box setup, where everything will definitely work. Because before checking, he made sure that at least things are working. Then only he checked in. But when it comes to 2 machines, 3 machines, some configuration, it's not going to work as it is. So I'm going to cover this in my demo as well. The next step is automation of testing. Let it be your unit test, functional test, your acceptance test. First thing is testing frequently to avoid regressions, to test the new features, and as when possible, make sure that those tests are automated. The advantages of automation, if you pick up the theme, it's automation, 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 automation. Automate your builds, automate your deployment, automate your tests. Build, deploy, test cycle has to be automated. That's the theme. And once you have reached that stage, then there is another process which makes sure once you have said my automation testing has passed, there's another process which takes your builds now from your developers or the build drop machine to the production system. And then there's the next advanced stage. A lot of companies have never reached that stage of fully automating from your check-in to deploying it to your production. They have mostly stopped at build, deploy, test, and then there's a manual step or another trigger which then takes it and deploys into the production environment. People don't refresh their production environments day in and day out. So test automation is critical. Make sure that as developers you have the unit tests written. And the other thing is there has to be some organizational change which needs to be inculcated. A lot of times there's a mental model in the mental model that quality is for quality assurance guys. I'm not really concerned about quality. But I think it's the team which owns the quality. Sorry. And the continuous delivery, what it talks about is testing shouldn't be a phase. It should be as seamless as your other activities. The other umbrella activities you carry forward day in and day out. So make sure as developers you write unit tests. Make sure your testers, when he is testing, does the automation, and there is an acceptance test make sure that your stakeholders or your end users agree to what your developer is fixing. So I'll now spend most of my time going forward on the demos. So what I have is, I have a web application, a very simple application called as Tailspin, which sells you some airplanes, though it sounds a bit ironical, but it sells you airplanes. And my project is stored in the Team Foundation Server 2010, and I'm going to use all the rich features of Visual Studio Ultimate, Team Foundation Server, and the latest test and lab management features which my team builds. And my laptop configuration, I have a 8 GB laptop, and I'm running a couple of VMs on top of it to show you a bunch of things here. And everything is based on my Hyper-V, Windows Server 2008 Hyper-V. So four themes, high level, I will be covering. How do you create production-like environments? How do you file rich bugs so that you don't hit the problems like non-reproducible bugs? What does it mean to be a gated check-in? And the automation of the build, deploy, test workflow. That will kind of put the overall theme around it. So let's move to the demos. So what I have here is my Visual Studio, the standard ID. And I have this project called Tailspin. And it has its own solution, which is checked into my source code. So once again, make sure things are checked into your source control. And keep checking in frequently. Don't hold your check-ins till you have X lines of code. Don't keep that as a criteria. As soon as something is done, it's testable, check it in. So that's the policy which is followed, let's say, by this team. And even their test project is part of their source control. So, and what I'm now pulling up this is the, how many of you have seen this Microsoft Test Manager before? Not. Okay. So this was part of the one of the new products which was launched in the April 2010 with the Visual Studio 2010 offerings, and it's available as a separate SKU and as well as the Visual Studio Ultimate. So it has primarily two centers here. One is the test center and the lab center. So what I'm currently seeing is the lab center here, and what we have is here is the list of environments which are available. So before I move forward, let's spend some time, what do I call environments? So for me, environments is a collection of machines which actually mimics your application. So let's say you have a typical 3-tier application, your web server, your DB server, and a web client. So how would you test that application? You would have 3 machines which resembles your application. You might test it on a single machine, but ideally 3 machines as your customer would be using it. So that's what I define an environment. So now it takes a lot of time for a tester to actually create this actual environment which customer is using, because he needs 3 machines. Getting the resources is a problem. Once he has the machines, he needs to make sure that proper OSs are installed as the customer would be using. Then he needs to install IIS, SQL Server, some application. Everything has to be done, and it takes a lot of time. That's why we are hesitant to actually use the customer production-like environment. Now with this one, we would be seeing how easy it is to quickly create production-like environments. So this is built on top of virtualization platform, Hyper-V and System Center Virtual Machine Manager. So once I move into the library section, I have a section here called Virtual Machines and Templates. So it lists down all the, sure. I'm not sure if I would be able to do that. I doubt. Is it really bad? Not readable? I'm really sorry. I can't increase the font. Okay, thanks. So what you see here is the list of my templates which are created in library. So all in all, what it boils down is there's a library, and you can like check in, check out books from the library. You can actually, these are the templates of the virtual machines which you can check in and quickly create environment out of it. So there are a bunch of templates available here. So this is some web client, this is some server, and some Active Directory. So another thing which is of interest is customers would have their own domains, and we typically don't create our own domain to test it. So that's another cause of a lot of problems, because there will be some domain issues, there will be some different domain policies which the customer is following, and we are not able to mimic that. Because it takes a lot of time to create a domain controller, make sure that all machines connect to it, and there's an Active Directory around it. So what we have is, we have templates created for these standard images which are used very frequently. So there would be a lab administrator or one of the system admin guy who would create these templates once for all with the right application prerequisites installed. So you could have templates. Let's say I want an application, virtual machine with SQL installed, another virtual machine with IS7 installed, all those things. So once someone has created these templates, now let's see how someone can quickly create an environment out of it. So he says new virtual environment. So let's give it a name, GDIS demo. And you can specify where does this environment gets deployed to. As of now, I have only single resource pool, because everything is on a single laptop. So it would show you all the machines which are available. So I put one server here, and I can now rename it, let's say, my GDIS_DB. And then I can change the role of this one to my database server. Then I add another template out of it, and I'll rename it to, let's say, similarly make it as my web server. And there's a readily available web client also available. I'll just rename it a drop and actually deploy the application from the drop to this environment. And then we also have another cool feature called network isolation, which helps you create environments which are isolated from each other. What it means is, those machines in an environment can communicate to each other seamlessly, but they are isolated from the rest of the world. This is more mimicry of the customer's environment. They are not talking to the rest of the world, but they are communicating with each other. So you can even turn on these capabilities, and you can even add domain controller machines and say this is my AD, so it won't be connected outside. So you can select the required capabilities, and this is the summary of the environment you would like to create. I'm not going to actually create it because I don't have enough resources on my single laptop, but the overall idea is that creation of environments eventually will boil down to a couple of clicks, check the machines which you want, and give it a name, and that's it. So I actually already have an environment created, so I'll use that for now. So I have a couple of environments created here. One is the single machine environment, and then the other one is the actual multi-machine environment using two machines. One is the database and the other one is web. And you can do a bunch of operations on these environments. You can start, stop, pause the environment. And another cool thing which we have is this mark in use. At times, what we have seen is I'm using a machine and I'm actually doing RDP into that, remote desktop. And someone snatches my session. How frequently does it happen? A lot of time. What do you eventually end up doing? Open up a notepad, I'm using it, Hariveer. Doesn't work. So what we would like you to do is mark your environment in use with your appropriate comment, GIDS demo in progress. Do not touch. So the overall idea is that there should be seamless collaboration between the various team units so that you don't stumble on each other's foot. Everybody should be able to create environments as per its own wish. So once you have this environment created, now if you say connect, this is what it would launch up. So we call this environment viewer. What it eventually is, you would have struggled with multiple remote desktop machines, and how do you manage that? This provides you a seamless experience for managing multiple machines and doing the remote desktop into it. So this is what we call as environment viewer, and this gives you other capabilities of snapshot. Since all of these machines are actually virtual machines, you can quickly take snapshots. Now the advantages of snapshots is the way I have the snapshot called clean OS plus prerequisites, which means at this state, the environment is clean, they are blank, they are clean images without any simple OS and my application prerequisites. It's a pristine environment. So what if you don't use these technologies, what would happen is you create an environment, you deploy some build on it, and it just messes with your system. You can't completely uninstall it cleanly. Because your application is still in development phase, the uninstall doesn't work clean. What would you end up doing is mucking up with registry, deleting some files manually, and struggling here and there. So what it enables is, with one click, you can actually go to the clean state of environment. So, and this is, I'm going to cover further as well on what does it mean to have this daily builds. So once you have this environment created, now let's see how someone can use these environments to create rich bugs. So this eventually boils down to that no more, no repro thing where your testers files a bug and developer says, I can't repro. He sends back to the tester. Tester would enable some logs, some traces, and again attach it to bug. Once again, developer machines it, everything works. So there's this constant bug ping pong kind of happening. So how do you eliminate this bug ping pong and have the rich information available to the developers so that he cannot refute that, he cannot see this bug. So let's move to this testing center here. So under the testing center, what we have is you can actually author your test cases, test plan, and test suites. The QA folks from this audience can very well relate to it, how important it is to do these things. You should have your test plans created. A lot of people actually end up doing these things in Excel and then managing Excels. Once again, it's not in your central store. These things keep floating around your emails. Some employee left, you don't know what happened to that test plan. Who wrote it, where it went, just gets lost. No traceability. So make sure that things do get in your central store. So I have here a test plan and multiple of my sub-test plans, something for my end-to-end integration, some negative test plans. I want to make sure that all the negative test cases are covered. So I'll move on to this test section here. So let's actually execute this test case. So as part of execution, I can specify what's my environment against which I'm testing. So if you see here, I can choose my environment, which I was just playing around with, and which was the build with which against I'm testing it. So once I click on test run, it would actually launch what we call as a test runner. So test runner has the capability of collecting a lot of information from the environment. So we'll look it into a second. And what it does is, I'm going to validate a test case which says if you give some discount code somewhere in your application, your premium customers would get some discount, which might not happen in this case, and we'll see how quickly can someone file a bug. So you just say start test. So what it's currently initializing is what we call as data collectors. So it's actually collecting a bunch of information from the local machine as well as from my environment. So these are the test steps from my test case. Open an Internet Explorer, go to the application homepage, click on something, do checkout, apply some discount coupon, make sure that things work. A very standard, simple test case. So I'm going to execute it pretty fast for the sake of time. My Internet Explorer is open, so I can mark this step as pass and fail. What you see here is, okay, my application homepage is already open. Click on model layer panes. Okay, this step also passes. And then click on some blue yonder and click on add item to cart. So this step also passes. Then the next step is enter some discount code and make sure that you get some price get discounted by 10%. So I click on that. Okay, I was expecting this to fail. It's interesting. Okay, there's a go button here. So application has given some error, some weird encryptic error which you're not able to correlate. So what's the best proof a developer can do? He would bring out his snag tool or snip tool and then take a screenshot. So let's put some comment also here, server error. And what you have to do, take a screenshot and clip it. What I'm going to do is, you can do all those things right from the tool and say, take a rectangular screenshot. Now this screenshot is automatically attached to the bug, to that particular test step which failed. Other thing which I would like to just show you here is, you can actually take the snapshot of the environment. If you take the snapshot of the environment, what it will do is, this snapshot environment will also be attached to this test step. And once it is done and a bug is filed, your developer would actually have a link of this snapshot. And he can directly click on it and reach to the exact state when this bug was seen. So the whole idea of non-reproducible bugs can be achieved by this thing. Run your tests on virtual environments, take snapshots when things fail, automatically attach snapshots to the bugs, and as developers, you have the snapshot links. Click on the link, it will directly take you to the stage where tester was seeing the bug. So that's the whole philosophy here. So we can actually go back to the environment and see the snapshot is being taken. So the exact state of these machines can be captured seamlessly just with a click of a button. Otherwise, what you would have spent is enabled a lot of logs and then try to reproduce the same issue. And there's a fair chance the next time you try to reproduce as a tester also, you might not be able to see the issue. You will say transient issue or something like that. So once you capture the exact state, you would, so this is what we have is, a snapshot file is attached to this test step. And now what I'm going to do is, I'm going to say create a bug. So it's collecting bunch of information. That's what we are going to look into next. All the diagnostic and data adapters from both the local machine and the environments would be collected. So this is the bug form which it opens up. And interestingly, it also has these video links. So what exactly tester was doing is captured, so the developer doesn't have any excuse. That's our whole philosophy. And if you look down, there's an action log also available here. So action log is all the actions which the tester performed. And the other interesting point is, from this action log, you can actually create coded UI tests. You can create UI automation tests directly from this action log and make it part of your regression suites, which can run nightly. So I am not going to demo it, but if you go to Visual Studio and say create a coded UI test, which was once again the new offering from the 2010, point it to this test case, it would actually use this action log file and create a UI automation test out of it. As simple as that. So what I'm going to do is just cancel this for now, and in the interest of time, move faster. So overall, the theme is just type in the title, assign it to your developer, and the bug is filed. I forgot to show a couple of other things actually. So let me just pull it out again. The rich diagnostic and data information. So this is the full system information of my client machine as well as my environment, which is already captured. So a lot of times you would ask this information from your tester. What was your config? Simple. A lot of times you would ask, what was your build number you are using? And then you would say, oh, this is an old build, this is fixed in latest build. Now go and check it on latest build. These things happen very frequently. Oh, I haven't tested on this config. This config is not supported. You keep asking for this information. So what we have here is, all this information is captured automatically and attached directly to the bug. What were the test cases which the tester was using? What are the other interesting links here? What was the event log? Another thing which we generally ask for. Did you enable traces? Did you capture event logs? Why does he have to capture? Everything is captured automatically here. Action log, the video file, and as well as the environment snapshot. So let's move forward. I'll end my test here and move to the next scenario of, so we covered how do you actually do the rich bugs, the bugs where all the diagnostic information is available so that we don't have non-reproducible bugs. Other thing which we covered is how can someone quickly create production-like environments to avoid that customer is seeing a problem that you don't see it. And there's a, so for that I'll move to the Visual Studio. What we have here is build definition. I'm going to edit it. Okay. Standard, some name. Now this is what is interesting. When does this build definition get triggered? So we have with 2010 bunch of offerings here. First thing is the manual. This build would be triggered manually. Whenever I want a build, I'll say go and generate a build for me. Next step, continuous integration. Someone mentioned they take a week to generate a build. What continuous integration philosophy is, every check-in produces a build. Every small check-in also produces a build. Even a resource file change would produce a build. So that if you do that, it would be directly related to your check-in. Whenever you make a check-in, a build would be triggered, put it in your drop location. It's your onus, go and test that build so that your check-in which you made doesn't cause any regression. Then there is rolling build option. So since there's a lot of overhead on continuous integration, because every check-in is generating a build, you might use a rolling build which says accumulate some builds and then accumulate some check-ins and then generate a build. That's another philosophy. It's like roll. Accumulate some check-ins and then again trigger a build. Accumulate some check-ins and then again trigger a build. Other option we have is gated check-in. This is also very interesting. So what it talks about is accept check-ins only if the submitted changes merge and build successfully. So it won't actually produce an official build drop, but what it would do is, it would gate that check-in, make sure your acceptance tests are done, there's no build break. Once everything is verified, then only it would produce the official build. So it's gating. So you have to qualify those quality gates to make sure that so what this would boil down to, there would be no build breaks. Otherwise your check-in would itself be rejected. So you can use these offerings of gated check-in so that there are no build breaks. Every build break actually causes the full team to hold on. And at times when we are working with the cross-geo teams, so someone in the US breaks a build, the cycle time is 24 hours. All the folks in India would be just waiting. Let the US guys come in, make a fix, next day we will do it. It's a vacation for us today. So the whole idea is to how can we be more productive and efficient by using some of these techniques, and it makes a lot of sense for a upper management, which makes sure that with a new tight business margins and new web startups coming every day, it's very critical that these philosophies are used. I'll keep it here for manual because I'm not going to check in code. So this is your standard workspace. And we have some build controller. So this is, I'm going to now dwell into, to cover the build deploy test. So I just briefly talked about the gated check-in. I'm not going to demo it heavily. So now what this invokes is my environment. So what it asks for is, what's the environment against which you want to actually now deploy this build? Once the actual code check-in is done, there's a build produced. Now what do you do with that build? I would like that build to be deployed on an environment and tested on it. So you can now specify the environment. So this is once again the list of environments which we have already created. So you would see that list here. Now this is another interesting thing. Now you can actually say, revert this environment to that state. What it means is, I have this clean state, which is a pristine state, which was created once. I would like every time my environment to be reverted to that snapshot. So at times what we have seen is testers are not able to test, or the application deployment fails because previous build was installed on it. Build over build install doesn't work every time. You have to uninstall. At times uninstall is not clean. Build over build installation doesn't exceed. So best option is revert the environment to the clean state. Just click that checkbox and you are good to go. It will take a time, so I'm skipping that part. So another option here is what's the actual build definition which will produce the code, which will actually generate and build the code. So what you can do is queue a new build and specify this is my compilation definition. Alternatively, you can use the select an existing build. The best practice once again is to use a queue a new build, which means you check in a code, there's a gated check in there, it produces a build, then environment state is reverted to a clean snapshot. The next step is your deployment. So if the snapshot, if the post-deployment snapshot is specified, so what we would see now here is automatically a snapshot would be taken on the environment. So, and it would be named appropriately with this build number. So this snapshot actually refers to this build number. So it will take another one which we took while doing that manual testing, where we said, I want to attach a snapshot to the bug. Then there's another snapshot which is now being taken. And if you see the name here, this is what it says, daily build, and actually the build number. So every build is now captured, and application is deployed on that build so that you can quickly right click and say revert. It's disabled because the operation is still in progress. So now you can actually say quickly revert to this snapshot. So once the test starts executing, you would see that once again the tailspin application, which was on the clean state, now a new build is deployed on that, and some UI automation is done. And if those passes, you would get a build summary saying that these were the tests specified, X number of passed, Y number of them failed, this was the build. So let's see how it goes now. So this is now blocked here with its lock icon saying running tests here. So this is also an indication for the other user, since you are running tests on this environment, do not touch it kind of stuff. So automatically it's bringing up the browser here, the Internet Explorer, and let's see how it goes. So it brings up the Tailspin application homepage, goes to some order layer lines, add items to the cart, and probably the test would end here. So this full UI automation is also integrated with this workflow. And if we go back, we would see the build report. So this is the overall build report. So this was my environment which was in use. It did not specify a clean snapshot. This was the build which was picked up. This snapshot was taken after the build was deployed. And this snapshot, there's a link to it. There was one test case which was specified in that plan, and that actually passed. So all in all, that full build deploy test workflow can be automated. You can use that gated check-in features. You can use the rich bugs so that there are no repro issues, as well as use those virtualization techniques and platforms so that you can actually do that production-like environments with a couple of clicks. So this is what we just saw. This is your traditional workflow. You compile the code. Because the build over build doesn't work, you end up actually re-imaging the machines. Once you re-image the machines, then you manually deploy the application, and then you run tests. So what we are now introducing here is compile the code. You don't need to re-image the machines. Just restore the environment to the clean state, automatic deployment of application, take another snapshot for future references, run test. Alternatively, you can restore snapshot during run test also. That's another interesting thing which I wanted to talk about. So I think I'm running out of time. I'll take that offline, really sorry for that. So quickly summarizing, the overall theme is reduce environment setup costs and application deployment setup costs. Use your hardware, utilization of hardware using virtualization techniques, and bug fixing made easier, both with the diagnostic data adapters, which I talked about, the rich bugs, and the environment snapshots. These are the quick resources, and there's some interesting stuff on our blogs, as well as we have a demo virtual machine which you can try out all the scenarios which I mentioned here. So quickly opening up for questions. I know I'm running out of time, but questions, feedback, love to hear about you.
say for example, in a day I'll get four bugs, and for each of the bug, I take a snapshot. So don't you think for each bug, taking a snapshot, again, I know it's an optional, but again, taking a snapshot for each bug, it's putting a burden on the server.
That's
each
actually
snapshot could be 3 to 4 GB.
So that's actually a good question. So one thing is, each snapshot would not be 3 to 4 GB. If you take a snapshot, only the differential would be written to the disk. So what it's today and what you actually deploy. Let's say if you install a 500 MB application, so now you take a snapshot, you would actually be consuming only 500 MB. So it's a function of how much space you have written from a snapshot to snapshot. Other thing is, so we recommend the snapshots only for the bugs which you think are hard to find and hard to debug. So you can use techniques and understand if this bug is a simple UI thing, some image is not proper, you don't actually need to take the environment snapshot, just take a screenshot, that should be enough. But for some hard to find bugs, this comes in really handy.